Hello there. This is your classmate Jay from Udacity CS 101. And while I was working on Unit 4, Problem 6, counting clicks, I had a little bit of difficulty keeping it straight which brackets, which opening brackets matched up with which closing brackets, and exactly what the shape of the data structure should be for the solution. And I had some syntax errors, some runtime errors, and just an all-around tough time. And that led me to develop this list notation. And the list notation is highlighted in this blue box. And this is just another way of documenting or notating a data structure. And so here's the data structure in question up at the top. This is what we want it to look like. And one method of documenting that is, as I've shown in this list notation. And it has a couple of interesting features that I wanted to point out to you. And it's very similar to the logic that we're using in the program. So in our function add to index, we use logic like for entry in index, meaning for each entry in the index. And so index is the outer list. And so really to explain the idea very simply, it is just this, that each set of matching brackets will be written on its own line. And although these items are written on their own line, it represents the same data structure that you see here. So that's the idea in a nutshell. And just to go through a couple of examples to show you how it works, here we have for entry in index. So here we see that we know we need a for loop when we see that it's a dynamic data structure. We don't know how many elements are going to be in the list. So we have our list index. Here's the name of it. And so we have 0 to n entries in index. And then we can see that inside of entry we have two items. We have the 0 index item is key or keyword, and the first item is this sublist here. And this sublist we're going to call URLs. So that's a static list. And why are we calling it a static list? Because it only has two elements. So each entry is just going to have two elements, the key and URLs. And URLs can have more sub-elements, which it does. And so, for example, URLs is made up of URL items. And a URL item is made up of a URL and the count. And so you kind of see the notation. What it does is, for example, the 0 here and this 1, they're written next to each other at the same height, so that you can easily scan across and say these two things go together, just like this 0 and this n go together. And this shows you, hey, this is a dynamic data structure. So there are 0 to n items, URL items, 0 to n URL items in URLs. So let's take a look at some more stuff here. So we see with entry, there's, again, it's either two parts. You've got your key, you've got this part. But entries, you have 0 to n entries in index. So I guess I'm really saying the same thing multiple times. I'm going to kind of leave it to you to look at this and play with it and see if it's helpful. It may or may not be. It was really helpful for me because, when you get, so for example, at the very bottom here, we know what is it that we want to append to index? So index is a list. It's made up of 0 to n entries. So we're going to append an entry. Well, what does that data structure look like? And here you can see we can count. It's got 1, 2, 3. So we've got one bracket, then we've got our keyword, then we've got a comma, then we've got 2 opening brackets, then we've got our URL, and we've got our count, and then we've got 1, 2, 3 brackets. 1, 2, 3 brackets. And it's getting a little messy here, but this is what was really helpful for me, is really being able to keep track and count these brackets. So let me just clean things up here. Okay, so the closing brackets, being able to go, okay, inside of each entry is going to have 3 closing brackets at the end of it, like that. And the total data structure has 4 closing brackets when you're including the index. So it's just a way to visually see what's going on, and you can also see what we have. We have a little legend over here on the right-hand side, and we took a couple extra steps in our solution where we defined an internal local variable called key, and then we tested if key is equal to keyword. In the solution provided, they use just entry with the index of 0. And we just went to a couple extra steps to name these things and then perform the test so that the names of the things make sense and we can reason about them. And also just to keep things straight. So I think I've covered about everything, and I don't know if there's anything out there like this. There probably is. If you know about something like this that could be helpful for us, please share it with the class. And if this is helpful for you, I'd also enjoy hearing that, or if it was confusing, maybe what I could do to explain it better. And with that, I wish you a great day, and we'll see you in class. Bye-bye.